All right, so this is part of the reset program. The title of our lesson is actually Housing Design Technology, 10 to 12 hours for the lesson. I'm Betsaida Arias-Hoskins. With me, I have Alicia Thomas, and I have Level 1, Alexandra Green. Thank you, Alexandra, for being part of this group. As a subject, it's actually Applied Engineering Design, grade level, middle school. This is actually the list of some of the materials that we're going to be using during this lesson. I'm just going to go over really quick. We have the standards as well, the science. We have math and English. And then we're going to talk about the objectives. The students are going to be able to use realtor.com to find an example of a single family that fits the criteria of the project. Number 2, Alicia.
Number 2, demonstrate an understanding of the AEOP process while utilizing each stage to successfully complete a team challenge.
Thank you. Number 3 is use the engineering design process to create a 2D blueprint and 3D design for a single family residential house.
Use CAD, which is short for Computer Aided Design Program, that allows them to design their homes to be 3D printed.
Number 5 is convert full-size measurements to scale size and scale size measurements to full size using proportions.
6, recognize scale drawings of items as a similar figure to the original item.
And then number 7 is create a physical model of home using balsa wood and glue. Just really quick about Dr. Knight, he's actually the Director of Learning and Sciences at the University of Southern California Institute for Creative Technology. He's been a wonderful mentor, and he's actually, for this lesson, we actually use the Open Tutor, which is an open source and user authorizable tutoring chat dialogues that he actually created with some other teachers or some other colleagues. The STEM careers, we have the computer science, software engineer, civil engineer, and industrial engineer. The first part right here is engagement. As a part of the description, the students are introduced to one real-life problem that can be solved by using the engineering design process. First, the students will review the stages of the EDP with a slide presentation, and then each student will design a vegetable garden and share their findings with the class. So really briefly, this is actually the engineering design process that the students should know already. They should have a background about this. This is only just a review at the beginning of the class. Then the students are going to be able to watch the engineering process video, which I believe I have it open still, to review the EDP steps. This is actually a 5-minute video, which is going to be tremendously and very helpful for the students. In here, I also took the screenshot for the steps of the engineering design process. Number 2, each student will sketch a vegetable garden plan. 3, the teacher will have the students fill out the vegetable garden design quiz. And number 4 is next, the students will share their drawings with the class and discuss the vegetable garden design quiz. I have the quiz open right here. It shows really quick 2 different examples about the layout that they should actually draw, just make a quick sketch. And then there are 3 different questions right here that they have to fill out, and then you can actually discuss with the students in the class about their findings, if they're correct, and everything that happens in there. As part of the explorations, the students actually are going to begin the stage 2, which is generate ideas by working individually to draw a blueprint of a 1-story house. That's part of the EDP steps 2. In here, the students are going to work individually at the beginning, and then actually they're going to do discussion groups. The students are going to read throughout the scenario together, stopping and discussing at key points to share ideas and consider the requirements and constraints as they move through the engineering design cycle to design and implement a solution. EDP stage, select a solution. So here I have the scenario. In this case right here, the students are going to build a residential community of affordable single-family houses in the suburban area of Washington, D.C. The developer would like to build a community of 1-story houses that would appeal to first-time home buyers or small families and maximize the acres to produce the largest number of houses. The students must work in teams of 3 to 4 students to design, construct, test, and redesign the house whose requirements and codes must meet. In this document right here, if you see there are different links, actually this is the same thing as our lesson plan. Is actually, this is only for the students, and I think it's going to be very helpful for them just to kind of go through the whole lesson plan where they can find all the links and everything that they're going to need. The requirements are here, and the codes as well are here. And this part, the students are, of course, they're going to start with the 2D sketch. It's very simple. They're either going to use Kami or Google Document. The Kami right here, I took a screenshot as well. This is my example. As part of the requirements, the house is actually a 3 feet by 40, and each grid in this case is actually 2 feet or 24 inches. So if you look at my example, the small bedroom is 10 by 7. I put actually the lines are color coded. The full bath is actually 7 by 5. The master bedroom, if you look at the color, is green, and the measurement is 10 by 18, and so forth. It's actually just to help the students to give an idea of what they need to do. That's actually for Kami. If you guys don't have Kami, you can actually work with a Google document, which I have an example writing here. This is a screenshot, but if you look in here, I have a link to get to that. So the same thing, color coded, is going to be tremendously very helpful for you. And if you look also, let me see if I have it open. This is actually the student version. If you know how to use this, just basically you can find any grid paper or anything that you screenshot, you can actually put it in here. You go to insert, drawing, and then new, and then you can create that part. Otherwise, you can use the one that I have if it's okay with you, if you like it. Just double click, just let the students double click, and then make the drawing here of their design. And after that, they have to click where it says save and close. If not, no information is going to be saved, and then they're going to lose everything that they've been doing during the class. Number two here, the students are going to design after that the 3D house by either using Tinkercad or SketchUp. Those are two different softwares that they can use. If this is actually their first time using Tinkercad, I would highly recommend just to teach them how to use it, because for me, it's actually a little bit harder. It was a little bit harder compared to a SketchUp, but it's possible. If you have the time, go ahead and show the students how to use Tinkercad. I believe if you have the 3D printer, it's definitely better. Um, for the Tinkercad, I believe I have this document open, the housing design measurements. If you look in here, what I did in here, I created different tables. The first one is actually the 3D Tinkercad. If they're going to use the SketchUp, that's what they need to type in here, okay? And then conversion. When you use the Tinkercad, if you look here at the bottom right, which I'll show you the video shortly, there are different sizes. I actually use the 5 millimeters. It's up to the student what they want to use. And then the color coded is red color for the small bedrooms. And then they can actually type in here the sizes, same sizes that they have in here as well. This is actually my Tinkercad. Let me actually open the video over here because I had to close it before. But this is basically what I did with my Tinkercad, how I actually designed the house at the beginning. There are different ways that the student can actually play with this. Like I said before, they need a lot of practice to get better in using this. I don't have the time to go over the whole thing since it's actually 8 minutes and 47 seconds. But let me see if I can actually move it forward a little bit. Just fast forward a little bit here. But you see the colors, everything, and it shows in the video very clearly how to do that. And then they have different ways that they can actually move in here, the 3D part. And just let them play around with Tinkercad. Okay. Uh, this is actually the final screenshot that I have for that one. And then this is actually the SketchUp. I did actually record a video for this one as well. For me, SketchUp was actually more friendly. But like I said before, the students, they're really good at technology. Probably they're going to catch up on the Tinkercad easier than me and faster. So who knows? But if you don't have the 3D printer, you might as well want to use the SketchUp at the beginning until you get a 3D printer and then start using the Tinkercad. It's up to you how you want to design that. What I like about this one is if you notice, you can see the scales right there. While in Tinkercad, you cannot keep the numbers up like this way. So when you do the evaluation for the students on this part, you can see the numbers and make sure that the students actually follow the guidelines. That's one of the things that I like about SketchUp. It's just easier, I believe. It's actually, you see the ruler and everything, it shows the numbers. I believe it's like actually easier, but like I said before, for 3D printer, Tinkercad is much better. Okay, Alicia, if you can go ahead and start with explanation.
Okay, so the explanation, as a class, the students will discuss the EDP process stage 2,
Mm-hmm.
and they're going to generate ideas, which is stage 3, and select the solution for the project. And after looking at each other's sketches, they're going to give each other feedback as a group and use the think, pair, share technique to have a discussion about the 5 questions that are listed here. There's a link to the worksheet.
Mm-hmm. Thank you.
Yeah. So after they're done with that, and then they're going to go to stage 4. So far they have done a 2D sketch, then they've done a 3D sketch in one of the softwares. And now what they're going to do is they're going to sketch on graph paper. And they're going to use that sketch in order to create a physical model using balsa wood and glue. And in order to grade those, you're going to look at the rubric. We have the rubric included.
Yes, let me show it right here.
And so this is the rubric. So the rubric is for the blueprints and for the model. Okay. In step 3, there is a video there that shows them how to build a scale model house. And there's a picture of what it would look like, or a possibility of what it would look like.
And the video is only 5 minutes.
This is the checkers game where grandson and granddad will bond.
5 minutes and 55 seconds. Let's see.
I'm Chad from Chad DIY. Today's project is a scale model of a house.
Okay. And so another opportunity to take this project a little further is to let the students 3D print their model if you have access to one.
And on the evaluation part, the students will be using stage 5 and 6 to present their results and provide an overview of the activity. Make sure your students have a basic understanding of the key concept. Also, in our lesson, we used Open Tutor. And in Open Tutor,
so this is actually the part, thank you, Alexandra. This is actually the part that we use to create Open Tutor, which thank you, Dr. Knight, tremendously to introduce us to this program, because at the beginning we didn't know how to do it or how to work with it, but then eventually we definitely came up with the idea on how to work on this one. And thank you tremendously for your help. In this part right here, if you're going to design an open tutor, you definitely need to type here your introduction, then your question. And this part is in terms of the EDP steps. What did you do to design your one-story residential community? Then you come up with different expectations. And for us, it's actually 5 different expectations. If you look in here, the first one, just to give you an example, it says in the EDP stage 2, generate ideas, recreate the sketch or blueprint as a 2D model. And then I actually provided 2 different hints. The first one is actually, what did you use Kami or Google Drawing to do, and what stage was that? And then what did you make for the generate ideas stage before you made a 3D model? This is actually your version. This is what you're going to create. Then I'm going to stop sharing my screen right now so Alicia can show you the student version. Okay, Alicia, go ahead. Hold on one second. For some reason, the video is running. Okay.
Okay, so this is an example of what Open Tutor looks like from the student point of view. You have different prompts, and when you type something in the box as an answer, it will give you, it will keep going because we have those expectations set up in the back. So they're like questions to refresh the students' memories to make sure that they are getting those key concepts. So I'm just going to type anything in here, and it's going to be the wrong answer. And I don't know why this keeps happening, but
let's try to refresh the page and see if
yeah, I did that.
you did it. Okay.
Yeah. Yeah, we don't know what happened. Please try again or later or contact your teacher.
Yeah.
But this is Open Tutor. And again, this is an open source software, so it's available. You just have to sign up with it, and you create those peer, those questions, kind of like Khan Academy, and they have hints there to help you build on or refresh your memory. You're able to continue to, again, make sure the students are understanding those key concepts.
Let me see if I have to close my part on Open Tutor and see if that actually works. Okay, try.
When they presented in the meeting branding group, it didn't work. It didn't work either.
Okay. All right. So I'll talk to Dr. Knight about that. All right, Alexandra, go ahead. Thank you, Alicia. For the procedures.
You have to share your screen.
Oh, I'm sorry. That's right. All right. So this part right here is just the procedures for evaluation. Go ahead, Alexandra.
Okay, next we'll have a formative and summative assessment. The formative assessment, the students will be assessed through peer feedback after the first design process. And for the summative, the students would use the attached rubric to assist the students' housing.
Which the rubric is basically the same rubric that Miss Alicia was actually showing in this video. So
okay.
And then you want to talk to him? Yeah. Go ahead.
And below we have our references. We use Better Lessons. We use Housing Design Challenge, Science Buddies, Teach, Engineering, Try Engineering, and Vista Print.
Vista, thank. Okay. And this is it. This is actually thank you. This is actually our presentation. Thank you guys, and thank you for being patient with us. And thank you, ladies. I'm gonna go ahead and stop my presentation, and then I'm gonna stop recording. Hopefully, we got everything.